welcome back to my new video. Today we'll try to solve the seemingly tough questions. Yes, calculus can be sometimes quite terrifying, but when you try to solve it with the easiest methods, you will feel that calculus is in fact easy. So today, with some few steps only, we'll try to solve these three questions. First, we'll solve this question. I forgot to add the limit theta tends to 0. So I've added it right now. So this, I have limit theta tends to 0 sine theta raised to 1 by 3 divided by theta raised to 1 by 3 multiplied by theta raised to 1 by 3. So I multiplied and divided by theta raised to 1 by 3. Then I have log 1 plus 3 theta. I'm multiplying and dividing it by 3 theta. Okay, multiplying and dividing it by 3 theta. Then I have tan inverse root theta whole square. So I have tan inverse root theta divided by root theta. Okay, and I'm squaring it. Then root theta I am squaring it, multiplying and dividing it by root theta whole square. Okay, then I have e raised to 5 cube root of theta minus 1. No, so that also similarly e raised to 5 multiplied by theta raised to 1 by 3 minus 1 multiplying by 5 into theta raised to 1 by 3 and then dividing it by 5 theta raised to 1 by 3. So here you can see I have a very important result of limits, that is limit theta raised to 0 sine theta by theta, I'll get 1. Similarly, for log, I have limit theta raised to 0 log 1 plus theta by theta to be equal to 1. Using that identity over here. And then I have another identity, another very important result actually. Tan inverse theta by theta, I'll get 1, and limit theta tends to 0 e raised to 5 multiplied by theta raised to 1 by 3 minus 1 by 5 theta raised to 1 by 3 also to be equal to 1. So when all of that equals 1, finally I will get limit theta tends to 0 3 by 5. Everything else will be 1, and then I will have this 3 theta and 5 theta raised to 1 by 3 only left. So theta raised to 1 by 3 and this theta raised to 1 by 3 will get cancelled off, and then this theta and this theta will get cancelled off, and 3 by 5 are left. So limit theta tends to 0 3 by 5. Since I have no variable theta over here, I have 3 by 5 as the answer. So here we come up to the next question. Limit n tends to infinity 1 plus x multiplied by 1 plus x square multiplied by 1 plus x raised to 4 up to 1 plus x raised to 2n with mod x less than 1. So this question is very easy. First, I'll equate it to limit n tends to infinity. Okay, I have 1 plus, I'll just write the question once more. 1 plus x square, 1 plus x raised to 4 up to 1 plus x raised to 2 raised to n. Now next step is a crucial one. Limit n tends to infinity. I'll multiply and divide by 1 by x. So 1 minus x into 1 plus x square, okay, up to 1 plus x raised to 2 raised to n. Now I have to divide it by 1 minus x2. Okay, so next, so from this I have 1 plus x also, no, sorry, I have 1 plus x and then 1 plus x square, no. So 1 minus x and 1 plus x, I'll get it as what? 1 minus x square. Then 1 minus x square plus, write it down, 1 minus x square, 1 plus x square. Next I have 1 plus x raised to 4 and up to 1 plus x raised to 2 raised to n divided by 1 minus x. So here to 1 minus x square and 1 plus x square, I'll get it as 1 minus x raised to 4. So next step I'll have limit n tends to infinity 1 minus x raised to 4 1 plus x raised to 4. I hope you can see the pattern right now where we might end up, right? So here I'll get 1 minus what? X raised to 8. Then you will have 1 plus x raised to 8 over there, and then I'll get 1 minus x raised to 16. It will continue like that. So finally I can guess it to be limit n tends to infinity 1 minus x raised to 2 raised to n plus 1 divided by 1 minus x. And when I apply the limits, I'll get 2 raised to infinity, that's infinity, I always write it as 8, infinity plus 1. Infinity plus 1 can be considered as infinity itself. 2 raised to infinity, I'll get, 2 raised to infinity, I'll get as 0. Anything raised to infinity is 0, no? So when I apply the limits, I'll get 1 by 1 minus x. There you get the answer. Here we have the third question. I'll rewrite the question here once more for my and your comfortability. So limit x tends to pi by 2 tan square x multiplied by root of 2 sine square x plus 3 sine x plus 4 minus root of sine square x plus 6 sine x plus 2. This might take a couple of steps, but then you will find it to be very easy by the end of this question. Okay, so limit x tends to pi by 2. I'll split this. What is tan x? Sin x by cos x. So tan square x, sin square x by cos square x. And inside the bracket, what I'll do is I'll multiply and divide it by the numerator. So when I multiply and divide the numerator, multiply and divide the numerator and denominator with the numerator, I'll get, that is, I'll just write the step, 2 sine square x plus 3 sine x plus 4 minus sine square x plus 6 sine x plus 2 multiply it by the same thing. So I have root of 2 sine square x plus 3 sine x plus 4 and root of sine square x plus 6 sine x plus 2 whole divided by the same thing, no? So root of 2 sine square x plus 3 sine x plus 4 plus root of sine square x. Here it's plus, okay. Here it's plus. The conjugate I have taken. I have not multiplied it by the numerator. I have multiplied with the conjugate of the numerator. Plus 6 sine x plus 2. Okay. That's why I have a plus over here instead of the minus. So next step, what I'll have is limit x tends to pi by 2 sine square x by cos square x, and here I will have 2 sine square x plus 3 sine x. I am opening the brackets. I have opened the brackets, plus 4 minus sine square x minus 6 sine x minus 2 divided by same denominator, 2 sine square x plus 3 sine x plus 4 plus root of sine square x plus 6 sine x plus 2. Okay. So what I have next is I can cancel off some. You can see, cancel off some terms. 2 sine square x minus sine square x, I'll get sine square x itself. 3 sine x plus 6 sine x, I'll get minus 3 sine x, and with minus 2 over there. So I can write it over there, no? So sine square x with sine square x minus 3 sine x plus 2 divided by cos square x with the numerator. With the denominator. So I'll just write denominator, okay, plus the same thing, the value over there, denominator. So I have reached here. Next, so in the next step, what I get is limit x tends to pi by 2. I had sine square x, sine x minus 1, sine x minus 2. I factorized sine square x minus 3 sine x plus 2, and I got this, okay, divided by, I have, instead of cos square x I can write, so instead of cos square x I can write 1 minus, sorry, it has become a bit messy, 1 minus sine x and 1 plus sine x. So I've got here 1 minus sine x and 1 plus sine x with the same denominator, okay, because there's no change in denominator. I'm writing it like that. I'm a bit lazy to write it all down again. So now I have sine square x sine x minus 1 sine x minus 2 divided by what, 1 minus, sine square x. Yeah, that's the previous step. Now what I have is, I can write this as minus sine square x multiplied by sine x minus 2 divided by 1 plus sine x. How come? Because I cancelled 1 minus sine x with sine x minus 1, so there is a minus that comes out. I have that over here. So sine square x multiplied by sine x minus 2 with 1 plus sine x, and the denominator just like that I have it, okay. So we are almost towards the end. Limit pi by 2, limit pi by 2. If I add the limits, if I substitute the limit, not add the limits, sorry, if you substitute the limits over here to all the x, you can find that I don't get in an x by x or infinity by infinity or 1 raised to infinity. None of these indeterminate forms did I get. I'm getting it in a very proper form, that is, I substitute it, I'll get minus 1 minus 2 divided by 2 multiplied by 3 plus 3. I'll get 1 by 12 over here. See, so from a very complicated problem that it seemed to be at first, we have reached over here. So why we cannot put the limit over here at first itself is because of this tan square x actually. So you will have tan square infinity, so you will get infinity multiplied by, I think you will get 0 over here. infinity multiplied by is something of some finite value, not 0, some finite value will get, which is not the answer we need, because it actually makes very less sense. So we did all those steps to reach over here. So these very terrifying problems, see how easily within a few couple of steps, for the other two problems it was even easier, we reached towards the end. So this is what calculus is. Doesn't it amaze you?